Hey everybody, this is Larry. This is week 4 of the Leetcode Daily Challenge. Hit the like button, or weekly challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. Today we have 2737. Find the closest marked node. Okay. I'm premium prom. Have I done this before? No. Yes. You know how I like new proms, so we'll see how it goes. It just, I was like, this doesn't feel like I've done it, but I don't know. Anyway, let's take a look. You are given a positive integer n, which is the number of nodes in a zero index directed graph, a weighted graph, and a zero index to the array where edges is just an edge. Right? You're also given a node S and a node array marked. Your task is find the minimum distance from S to any of the nodes in marked. Is it just not a shortest path? From S, and there's only one node, right? S is one node and any nodes in marked. Return the integer denoting the minimum distance from S to any node in marked. Okay. I mean, as we'll go through an example really quick. We have the starting, S is starting, I suppose. At 0, we're trying to go to 2 or 3, and it just goes to 3, which takes 4 rate, right? I mean, this is just a regular shortest path problem. I mean, I guess it is a directed graph, which means that, well, the paths are not symmetric, right? But that's fine. And there's not always a path from between both direction of the two node, but it's just the shortest path. Otherwise, I don't think there's anything too crazy about it. So let's get started. I mean, this is, like I said, shortest path. So you can just, I think one thing that I want to do is go mark to 0 set of mark, so we can do lookup very quickly. And then for weight and edges, we have edges in C list of U, append VW, right? And here it is directed, so we don't have to worry about some symmetry. And we start at the node S. And and this is a shortest path problem. And even though it's directed, I mean, I think Dijkstra is just the easiest thing to do. Or I don't know if it's the easiest thing to do, but like maybe there's a something particular to this problem that we can do. But Dijkstra is the simplest thing because, well, it's gonna be fast enough, right? All right, let's look at the bounds. I mean, n is equal to 500. We don't even have to think, right? You could even do n square or v square Dijkstra and it'll be fine. So yeah, so here maybe we just do best is equal to infinity times n, right? Setting infinity is equal to some big number, right? And then now we have to set the starting node is 0, 0. We have a heap, right? Heap q dot heap push. We set the distance is 0, the node is S, and I think that's all we need, right? And then while the heap is going on, we pop from it, we get the distance, which we don't care about necessarily, but it's nice, and the node from this, right? Oops. And when we relax, that's when we are Gucci, I think. Yeah, because this is Dijkstra. So if node isn't marked, then we return the distance, right? Otherwise we just do a regular for loop to go through the edges. I don't know why I said it so awkwardly. Right. Also, there's a rate. And if best of W, best of node, oh, that's just D, right? So best of V is greater than D plus W, then we want to take this path instead. So best of V is equal to D plus W, and we push it onto the heap. And I actually failed to do one key thing about this, right? What am I doing? Best of V and V, right? Which is that I have to kind of code the branch, right? Because actually for each node, because of even though this is monotonically decreasing when we insert new things in the node, it means that we want to remove other instances, right? And what I mean by that is that, let's say, and this is just regular Dijkstra stuff, for reasons around heap usage, the standard library, and we choose to do a lazy heap instead of, in theory, you can remove the old version of that's in the heap, But here, but since we can't do it quickly or cheaply, we'll just lazy remove it by removing it in the future. And the reason why you need to is, for this problem, maybe it doesn't matter, but for a certain problem, it certainly does. Because here, for example, if you have node, if you relax it multiple times, meaning that if you pop from it multiple times and you do the work that it does multiple times, it is only going to keep on expanding the graph, even downstream as well, and it just gets more expensive. You could probably imagine that. So yeah, so we have to write something like, if best of node is less than d, then we just continue, right? That means that this is not the best instance that you can. This is one way that I've been just used to writing it like this forever. But actually, maybe and I always have to remind myself, maybe a cleaner way, at least for visualization, for if you're a newbie or something like that, is something like that. Then now you can say done of node is equal to true, and then but before that, if done of node, then we just continue, right? Because the short idea really is just that you want this node to the concept of Dijkstra is that the first time you see the node, it is going to be its shortest distance ever. That's the greedy part of Dijkstra. So if you see it again for whatever reason, you can just keep going, right? That's really it. And then we have -1, and hopefully that's really it. In the sense that I make a lot of silly mistakes, but yeah. Oh, this is a heap push. I don't know why I will heap pop, but yeah. All right, let's give a quick submit. Hopefully no silly mistakes. And yeah, and we're Gucci. So yeah, keep the streak going. This is Dijkstra, so it's pretty standard. Each node will only pop once. Each edge and each other node gets popped or pushed once. So well, technically all of y times. So it's gonna be log y or something like that, or relog y is how you would say it, maybe. But yeah, that is all I have for this one. Let me know what you think. Thanks for watching, and yeah, stay. I mean, this is the shortest path problems. I feel like I have a lot of similar problems on the YouTubes. Today I'm a little bit tired, so that's my excuse. Sorry, friends. But if you do have questions about Dijkstra, let me know in the comments. But that's all I have for this one. Let me know what you think. I mean, this is pretty standard Dijkstra, so that's why. I don't know. I have so many videos on Dijkstra. Some days I just don't feel like explaining it. My fault. But yeah. Thanks for watching. Stay good. Stay healthy to your mental health. Have a great weekend, everybody. I'll see y'all later and take care. Bye-bye.